Hey y'all, pretty feeling relatable to Bruno Mars today, so I hope none of you are, because we got to get through these 9.4 notes on vectors. So there's a lot of written details on here, which makes it seem like it's complicated, but it's not going to be as complicated as all these words and descriptions are making it seem. So this first part is just creating a vector out of 2 points. So here we have, in this example, we're trying to find the vector between P1 and P2. And we're going to be using this formula here to do so. And that means we need to label these points. So we're going to label x1, y1, x2, y2, and then plug it into that formula. So the vector of P1, P2 equals x2 minus x1, comma, y2 minus y1. So 4 minus -1 is really 4 plus 1, which equals 5. So 5, and then 6 minus 2 is 4. All right, that's it. Next, we're talking just a little bit about unit vectors. Unit vectors are 1, 0, and 0, 1. And these kind of like are x and y, but we're using like I and j instead, and these are the unit vectors. Now we're going to be looking at how to add vectors. You're just combining your i's together and adding. When you're subtracting, again, you're subtracting your i's and then subtracting your j's. When you're given like a scalar value, that's when it's like 3 times the vector. You just distribute that 3 to each I and j in the vector. And then lastly, this magnitude formula that we're given, we will use. So we are given a v and w, and the first thing we're going to do is find v plus w. So again, when we're adding, we're just taking the i's of v and w and adding them, and then the j's of v and w and adding those. So we have for the i's 2 plus 3i, and then plus the j's of 3 plus -4j. And then when we add those, we have 2 plus 3 is 5. So 5i plus 3 plus -4 is -1j. Or we can write it as 5i minus j. Next, we have v minus w. So we're taking those i's and subtracting them, and then taking the j's and subtracting them. And the first number is always from your first letter. So we're subtracting the v minus the w. So here for the i's, 2 minus the 3, because the v was first. So the v number comes first. And that's the I, still plus 3 minus -4j. So 2 minus 3 is -1i. And then 3 minus -4 is 3 plus 4, which is 7. So 7j. Now we have that scalar value of 3v. So we have 3 times each value. So 3 times 2i plus 3 times 3j. So that's 6i plus 9j. All right, next we're doing kind of like a multiple step. So first we're doing 2 times v minus 3w. First you apply the scalars. So first you have to multiply each one by their 2 or their 3, and then we can subtract them. So let's do 2v first. So 2 times 2i plus 2 times 3j. So that equals 4i plus 6j. And then the 3w equals 3 times 3i plus 3 times negative 4j, which equals 9i minus 12j. Now we can subtract them. So 2v minus 3w. So 4i plus 6j minus, and you want to put this in parentheses, 9i minus 12j. We're going to distribute that negative inside the parentheses, and we get 4i plus 6j minus 9i plus 12j. And then you just combine like terms. So 4i minus 9i is negative 5i, and then 6 plus 12j is 18j. Okay? Then we have the magnitude, and that's where we're going to apply the formula of the magnitude of v equals a1 squared plus b1 squared. And here we're going to write what v is again, 2i plus 3j. And I'm going to label each one. So the 2 is the a, and the j from the 3 is the b. And then I'm going to plug in. So the square root of 2 squared plus 3 squared. That's the square root of 4 plus 9, which is the square root of 13. That's it. Just simplify. Alright, like I told you in class, we're going to skip the word problems for this year, and I'm going to go ahead and go on to this problem of finding the direction of the vector. And we want to find that direction in between 0 degrees and 360, or 0 to 2 pi. So first you want to draw what this vector looks like. So first we do the I, which is in the positive 4 direction. Then we go negative 4 down, the j, from where you left off on your vector of the I. Now, I'm guessing as you guessed it, looks like we're going to make a triangle right there, because we're trying to find those angles, the direction that this vector created. So we're trying to figure out what that direction is between the ends of these vectors. And you can, from the 9.1 section, we know the formula of theta equals the tan inverse of y over x. And since this would be in the 4th quadrant, we don't add pi. It's just tan inverse y over x. And so I'm going to plug in those values. Theta equals tan inverse negative 4 over 4, which equals tan inverse of negative 1. So theta equals negative 45 degrees. But as our restriction told us, we had to be between 0 and 360 degrees. So to map back to that point, we're just going to add 360. Because if we remember, when you add 360 degrees on our unit circle, you get right back to that same point. So negative 45 degrees plus 360 degrees equals, let me get my calculator, 315 degrees. I'm going to shrink this down a bit to fit that in. That didn't do what I wanted. Okay, move this over and say equals 315 degrees. And that's it. All right, let me know if you have any questions.